Hey everyone. Before I start with today's lecture, I just want to give you some context, which is this is going to lay really important groundwork for the design fiction assignment that you're going to do with your teams over this term. As much as I believe in creativity for its own sake, and I would happily teach a class on creativity for its own sake, that is not what this class is. This class is about your ability to apply your creative thinking to new and changing conditions. And the new and changing conditions that we may be facing that we will be facing, we just don't know exactly what they are, due to changes in technology, are really key and really important for you to practice thinking with. So, today's lecture is based on the work of Jim Gibson. Jim is a Calgary entrepreneur, innovator, and author. He's part of the Rainforest Group, which is a local organization dedicated to growing Calgary's innovation ecosystem. He wrote the book, The Tip of the Spear, which is about changes in technology that we're facing. A really cool thing is that he consulted with Mount Royal students at the beginning of doing this work. And so he is really thankful to Mount Royal students and seeks to return that generosity. And one of the ways that he does that is by letting me use these slides that he put together to talk about the future of technology. So I just want to credit Jim Gibson with the ideas that were the basis of what we're going to talk about today. So Jim thinks, and he has good reason to be able to talk about this based on the research that he's done, that in the next 10 or 15 years, our species will have, for the first time, all of the technology and tools that we need to solve the problems of the world. Now, I have to admit, I'm a little bit more pessimistic than Jim is, but I agree that the power and the opportunity for good that are facing us in the next 10 to 15 years are mind-boggling. But that comes with huge risk, because those same tools that we could use to solve problems also will give us the power to create problems, create bigger problems than we could have ever imagined. One of the things that's super interesting about this is that as human beings, we don't always have a good ability to think about the things that we've made. Roy Amara, who was the founding head of the Institute for the Future, had a really interesting way of putting this, which is to say that we overestimate how much change technology will make in the near term, but we underestimate what level of impact it could have in the long term. This is things like, that's sort of the, where's my jet car? That's sort of overestimating the impact of technology in the near term. But you can look back, this isn't all digital. You could look back to when cars were invented for an example of how we underestimate technology's impact over the long term. Because if you look back at when cars were first introduced, people thought that, they'd make a big difference for the rich people who own them, but they never imagined the level of change that we have today because of cars. For just one example of that, you could think about the fact that there were laws on the books about what to do if a car passed a horse on the road and scared the horse. The person who wrote that law underestimated the impact of cars in the long term. Another example of that comes from the mystery writer Agatha Christie, British, wrote, starting almost 100 years ago. And she looked back on her life and said, I never would have imagined that I would be rich enough to own a car, or that I would be too poor to have servants. And that was just a change in one lifetime. If you watched Downton Abbey, you saw some of this. The cars were just coming in, but the Duchess refused to have electricity in her house because she didn't trust it. We underestimate the impact of change. Jim Gibson developed 3 laws that he sees of technology disruption. One is that the slope of the curve is increasing. There's a good chance that that sounds like a riddle to you right now. So trust me, I will explain what I mean by the slope of the curve is increasing. You will understand that before the end of this lecture. If you don't, let me know and I will keep going. Furthermore, technology genies never go back in the bottle. And finally, our linear systems of organization, our linear systems of thinking about culture and society and managing change are not designed to handle the exponential changes that we are facing. There are some pretty huge implications of these laws. And one of the scary things is that I guarantee we are not going to predict all of the changes. We will be surprised. Some of those surprises will be delightful. Some of them will require really significant and creative problem solving and hustle. Okay, so let me talk about what I meant by the slope of the curve changing. What that means is I'm going to take you back to, maybe algebra, when you were doing equations that were making a slope on a graph. And if every time you move over, you add 1, you get a straight line. And it goes up as you go to the right, but at the same rate the whole way through. That's different if your change is exponential. One way to think about exponential change is to think about Moore's law. If you don't already know about Moore's law, it's named after Gordon Moore, who was one of the founders of Intel. In 1965, Gordon Moore published an article where he predicted that every year you would be able to buy twice as much processing power for the same amount of money. Same dollar, twice as much processing power. Over and over and over again. It's come close to coming true for 45 years. Now, the key phrase in his prediction is twice as much. It's not one of those changes that makes a straight line of adding 1 every new year. Instead, it doubles. And you can show that, most often we show that on a graph that has an exponential scale. So if you look at this represents Moore's law starting way before he came up with it, about 65 years before he came up with it, but applying it to changes in computation across different industries. And this looks, there's a little curve to it, but it's mostly straight. You could draw a convincing straight line through these dots. But you got to look at the x-axis on the left-hand side of the screen, where you'll see that it doesn't change going up, say, by 10 on every row. Instead, it changes exponentially, from 0 to 100 to 10,000. It goes up at an increasing rate the higher you get. So you may have seen this being called out. Kudos to you if you caught this, because it's really important, in charts for the spread of COVID-19. I hope that you were paying attention to the news and saw that some charts looked roughly like the one I'm showing. And if they were made by responsible information designers, there was a note saying, hey, this is exponential, because some people may not notice that. If you represent the same data on a linear chart, it looks really different. It looks something more like this. And that's because exponential change can start seeming like not that different. Day one, if you add $1, you get to $2. If you're doubling, same thing, you get to $2. Day two, if you add another $1, you get to $3. If you're doubling, you get to $4. It's still pretty close. And we tend to really pay attention to the short term. And we think things are going to stay basically the same. And in the short term, exponential growth can look similar to linear growth. It can make us get complacent. There's like the story about the person who has a pond and their lily pads are starting to get out of control, about doubling every day. So day one lily pad. Day two lily pads. Day three, 4 lily pads. And they think, okay, I got to do something about this. But it's kind of annoying. I'm kind of busy. I kind of want to do other things with my time. So I'm just going to put this on the back burner until my pond is about half covered. Then I'll figure out what to do about it. So if they do wait till it's about half covered, how long do they have until the pond is fully covered with lily pads? It's a lost cause. They have one day. The next day, it's going to be fully covered. That's what happens when growth is exponential. The thing that is even more mind-blowing about this is that some changes are happening even faster than Moore's law is happening. So one of those changes is the cost of sequencing DNA, of taking a DNA sample and going from, like whatever that sample is, to a series of A's, G's, C's, and T's. That used to be really expensive. It used to be astronomically expensive. But you can see in this chart that it started to fall. And at first, it was falling at about the same rate that Moore's law would predict. It's a little confusing here because you're switching from thinking about being able to buy twice as much with the same money. It's the exact same thing, but the inverse. You're buying, having to pay half as much for the same amount. And the gray line that says Moore's law shows how that rate would look on this chart. And the blue line is showing how much faster than that the cost of DNA sequencing has fallen. Now, this is super interesting on its own, at least it is to me. But it's not only happening on its own. Think about what industries might be affected, what parts of society. The justice system might be one that it would be affected by a lower and lower and lower and lower and a mind-bogglingly lower cost of sequencing DNA. And if it gets cheap enough, it could touch everything. Like, I could think about the beauty industry. 2001, sequencing was unthinkably too expensive to imagine using it, say, as part of a beauty product. But as the cost drops, like, I could imagine some companies saying, I bet that there's some connection we could make between someone's DNA and a moisturizer that would work really well on them, or something like that. So you need to start getting flexible in your thinking. You may already be, in which case you're in great shape, but getting even more flexible in saying, how could this affect things? How could the changes in DNA sequencing affect the pet industry, or fast food, or fashion, or transportation? Some of those may be clearer answers than others, but I bet that if you really put your creativity to it, you could find something. And, spoiler, you will, as you're working on your design fiction project. Okay, but I got a little on a soapbox there about the design fiction project. I'm going to come back to this technological change because what I was talking about was only dangling our toes into it. It gets even more challenging. That's because it's not just DNA sequencing and it's not just computer processing power. We're seeing similar rates of change, similar potential tipping points in things like the Internet of Things, VR and AR, 3D printing, synthetic biology. That's where we make the instructions to make a living thing. Materials science, being able to make, like, I don't know if you saw a few years ago, there were those amazing videos of you could spray something on your shirt, and if you spilled stuff on it, it would just roll off instead of sinking in. That's an example of a change in materials science. On top of these, we'll be seeing changes in batteries. Being able to change batteries is going to be a huge game changer in transportation. Blockchain and digital identity systems, how we pay for things, what we do with our money, that has changed society in the past, and this time it's about to change it again. Cognitive sciences, what we know about how our brains work and how to change them. Nanotechnology, the tiny, tiny, tiniest things, and how they could get out and make really big changes. And all of this is happening to affect our lives in social, mobile, and experiential realms. And that's not all. These things are combining. This is where it gets really interesting. This is where you have fantastic opportunities to use your creativity. Be ready to think about this next week when you do your first facilitated creativity in your design fiction teams. Thinking about how these things could combine and what that might mean. So, for example, if we had combined changes in robotics and drones, artificial intelligence, and VR and AR, I could imagine that I get something like an AR program. These exist from IKEA, where I get to see some new furniture in the room. Let's make it, for the sake of this, something relatively small, a new lamp. I look at it with my AR system. It's a lamp that I like because it's been suggested by the artificial intelligence that has learned my taste, and maybe even it's learned what sequence to present things to me in so that I'm at peak desire to buy when it shows me the thing it thinks I'm going to like the most. And then with robotics, depending on how the laws go, that might be, or with drones, that might be drone deliverable really quickly. So we've already got the speed of Amazon delivering. It could go way farther than that. So that example is a relatively tame way that these things could change. I want to really let you loose to go way bigger, way broader in how these things could combine to change society, change business opportunities, and change the problems we might face. Like, can you think of problems that might happen with delivery drones going into neighborhoods? I can think of some problems. I was at a rooftop bar in Montana a couple of summers ago, and someone was flying their drone around the bar, and it was about the most irritating thing that I've experienced. That's a problem. So I want you to think about the possible changes, think about problems they might bring on, and think about possible solutions. And that just happens to be the 3 phases of the design fiction project you'll be working on. So, to reiterate, each of these technologies that Jim Gibson listed and put together is changing at a rate much more like Moore's law than in a linear rate, just adding one unit at a time. They're approaching the takeoff point where we start to get really bad at predicting what will happen. And that gap in our ability to predict and what's coming is where we hit disruption. Now, you might think that disruption would cause us to say, let's back off. Maybe we don't want to use this technology. But never in the history of the intelligent human species have we invented something that was valuable or useful and then decided to give it up. It's just not how we work. It's not in our nature. We have forgotten how to do things, but we've never intentionally stepped back. So, these genies stick with us, whether that's something like figuring out how to control fire, inventing the wheel, inventing the printing press. All of these things get to us, they stay with us, and they get to us faster and faster and faster. Because you can see the time scale there on the left, again, is exponential. It's not 1 century, 2 centuries, 3 centuries. It's 100 years ago, 10 years ago, 100, 1,000, etc. Change is coming, and it's coming fast. Interestingly, one of the more interesting thinkers, philosopher Nick Bostrom, who's based at the University of Oxford and is the founding head of the Future of Humanity Institute, has predicted that AI will be our last invention. What could he mean by that? What he means is that if we invent a truly effective AI, it will start improving itself. And it will improve itself, and it will invent things at a race outpacing what we can do. He's got some really interesting warnings about this. If you're curious about it, I recommend his book, Superintelligence: Paths, Dangers, and Strategies, which is a super interesting look at how he tries to lay out how we should think about AI. There's a reason that we need that help, and that's because as I've been saying, we keep tending to think about things in linear terms. And that shows up in how we treat democracy and capitalism, how we treat education, how we think about energy. I actually have someone I know who is doing his doctoral research into energy transitions. And he says that if you look back at past energy transitions, you get something that looks a lot like this exponential scope. And he says if you're walking along this slope, everything looks normal. Everything looks like, yep, basically like last year. We're not going to say that this year, but probably most of the years of your life, you'd say, yep, it's basically like last year. There were some changes, but they were linear, or at least so they seem. But, and this example is from Jim Gibson, you could look at something like inequality. And if you look at the rate of annual growth in income for people in different income percentiles, as you walk from 20 to 25 or 25 to 30 or 30 to 35, these changes, they're there, but they don't look that huge. It would be really easy to look at the data really close to you and say, I think I have an accurate picture of what's going on. But that picture would completely miss that shift that starts somewhere between 90 and 95. And that is coming for us with all the technologies that Jim Gibson mentioned, assuming everything goes well, assuming that we don't face an even bigger change than we are able to think about. So I don't want to end this on the downer. I do want you to think about this as an opportunity, as a way for you to have a longer and bigger view than the people who are around you, because you're thinking, is this a linear change or might this be an exponential change? And if it's an exponential change, what could that mean? What do we need to watch out for? And what are the opportunities that might be hiding within it? Thanks.